think that's enough. All right, welcome everyone. Thank you so much for joining us tonight. So this is our first joint meetup of the month in San Francisco, and we're very happy to be here. So if you know who we are, or at least some of us don't know who we are, what Pacific Hackers is, or who I am. Well, my name is Marco Palacios. I'm the president and co-founder of Pacific Hackers Association, and you'll find out in a little bit who we are and what we do. But first things first, we have a no asshole rule. Okay, so we leave the egos outside. We are a community, we're a family, so please treat everyone with respect. I know everybody has opinions for everything, but keep your opinions to yourself. And if you're going to express them, please just be courteous with other people. Be respectful. Okay. So we're a 501c3 nonprofit organization. We're in a mission to fix a few things in the cybersecurity field. Number one, diversity. We want more women in the field. We want more people of color. Okay. Number two, we want to fix the education system. We know there's a lot of programs, universities that are offering programs, but in reality, when students graduate, they're not really ready to go into the workforce, right? So sometimes they have to come back, right? And everything that I'm trying to fix happened to me. That's the reason why I'm doing this. Number three is the hiring process. How many jobs do you see that they're offering junior analyst positions reporting a CISSP? We're trying to do that. We're trying to fix that by making the direct connection with the hiring managers. Again, just like it happened. Okay. And again, also we're trying to target minorities and veterans. Okay. We have a meetup that has been going on for 8 years. It started in South Bay. In fact, this is the first time we're doing meetups in San Francisco, because originally we started in South Bay, because back in the day there was nothing in South Bay. There was a lot in San Francisco. However, pandemic happened, and then a lot of the groups in San Francisco left, and then we stayed. And now it's time for us to grow, and now that's the reason why we're going to start having more meetups in San Francisco. So next week, we're going to have 2. So this is the first one today, and then next one in 2 weeks. And then, we're always looking for speakers, right? So again, these meetups are not run by just me. We're always looking for speakers to do it. Fun fact, a lot of people that have come through Pacific Hackers, they already spoke at B-Sides, RSA, Black Hat, DEF CON. Some of them remember where they came from, majority of them do not. So just give back to the community, share your knowledge. We're always looking for that. And we do a lot of collaboration with different associations. So OWASP we do a lot of events with them, especially in South Bay. WISIS, we're going to have a WISIS event, joint event next week with WISIS CCSF chapter. We also do it with WISIS Silicon Valley in different times of the year. So again, in fact, tomorrow we're going to be with WISIS in the Cybersecurity Summit in Santa Clara. So, long story short, but anyways. And again, today we're going to have this the first one here. So, thank you for being here. And then in 2 days we're going to have a pickleball event. So if you're into pickleball, please sign up. It's going to be at the Bay Club in Santa Clara. So I know it's far, but hey, it's going to be free food. You can bring your significant other. I think because it's a gym and it has sauna and other things, you can use the facilities. So again, please take advantage of. Pacific Hacker is going to be a Cactus Con. So I'll be speaking with my CEO, Jen Winters, and also another member of our team. She's going to be speaking as well. So again, we're starting to grow. So first started here, and now we're going to be in different places. So yeah, and next week, Max, we're going to be at DNA Lounge. Max is going to do a CTF walkthrough. You want to talk about it? Or you want to just
well, there isn't much to say. Pacific Hackers has a CTF, and we bring it to many of our events throughout the year, including Hacker Day. Last year we had a very successful run-through, and a lot of people were interested in seeing the answers to some of the challenges. So next week we're going to have a walkthrough of them. Step-by-step how to solve a couple of the cryptography and web application challenges.
Yeah. And Max is one of my volunteers. He's a CTF lead. And funny story, last year I gave him 11 month, hey, we need to create a CTF, blah, blah. But then I had a crazy idea of, oh, let's create an event in San Francisco during RSA. Oh, by the way, you only have 2 months to create this. And he and other members created it. So thank you, Max. And yeah, they did a really great job. Again, next week we're also going to have at CCSF, we're going to have the joint event with WISIS. It's going to be this girl from Black Hills InfoSec. She's going to be there. Who's going to talk about social engineering. In fact, that's what she does for a living. So coming from someone who actually is into this field, it's actually very interesting. So yeah. And for our women's, we have a Galentine's. It's going to be also next week in Oakland. So yeah, the first 2 hours is gonna be women's only. So men, I'm sorry, including myself. My organizer, she told me, please do not come the first 2 hours. I said, well, but I'm the organizer. I was like, no, but you're a man and men are not allowed. All right. So after 4 on, we have a happy hour, other stuff. But the first 2 hours from 2 to 4, it's gonna be a panel, and it's gonna be for women's only. So women's stuff only. So yeah. So FYI. Okay. We also going to be expanding, so SunsetCon, it's going to be our first conference in South California, March 6th and 7th. So again, if you know someone in the area and they want to go there, it's actually part of Scale. So if you're familiar with South Cal Linux Fest, that's basically what it's going to be, okay? And it's just going to be a small portion of Scale. So go there, and we're going to have good talks and workshops, including myself. I'm going to be, Max is going to be there, Alevsky, and we're going to be speaking. And last but not least, Hack the Bay. Hack the Bay, it's going to be on April 28th. It's going to be at the Public Works here in San Francisco. Long story with Hack the Bay. Like I said last year, I came up with the idea 2 months before RSA, and it was just going to be a 100-person gathering. Then the place say, oh, you can bring 200 people. I said, good. So by that morning, I have over 500 registrations, and the whole, I didn't know until, we start kicking people out because, well, not kicking people out, but not allowing them to enter because we can only fit that many people. So my promise to them was, we're going to go bigger next year. So we're having a Public Works, which is an underground club. And it's going to be great. So it's going to be on the Monday when there's nothing between Visa, San Francisco, and RSAs. And our Pacific Hackers Conference is going to be our 6-year anniversary this year. Starting in 2018, last year, 2024, we outgrow. So again, we've been growing and growing. And this year, we're actually looking for a bigger location because now there's so many people interested in it that we want to feed as many people as we can. Okay? And I just want to thank our sponsors, Sembra. Thank you for hosting, offering the place. So thank you so much. And also for Intrusive Lab. So thank you for coming all the way down here and going to do it. So also would like to thank all my sponsors because we cannot do it without them. So thank you so much. And lastly, I'll shut up in a few minutes so I can give it to Louis and he can do what he's known for. We always need your help. Spread the word. Tell people who we are, what we do, how we help people to get into this field. If you have referrals, tell them that we're here for them. If you're hiring, please let us know that you're hiring so we can point people your way. There's many people who are out of jobs right now, and we have a lot of talent out there. So let us know. If you want to speak, share your knowledge, here is the QR code. Please submit to the CFP for our meetup. And again, sponsoring, if your company can sponsor, like even just hosting a place, especially in San Francisco, DNA Lounge is not free, just FYI. But we decided that we wanted to have a footprint in San Francisco, so we wanted to go there. But, realistically, DNA Lounge might not be the best place. So if your company can sponsor us, just having the location, I will really appreciate it, okay? And join our Discord community. That's where we are. So if you're into Discord, please, let us know. Okay. And if you want to get a hold of me, here's my email. You can find me on Discord as SmartGraph. I'm also a goon at DEFCON, so you can also find me as SmartGraph. LinkedIn, Marco Palacios, or X, and Palacios. So with that, I just want to thank you so much. And now I'm going to pass it on to Katie, who's going to speak about OWASP. And yeah.
It'll be a lot shorter. We do not plan as far in advance as Marco does here. But thank you everyone for coming. Thank you SumGrep for hosting us. Thank you Pentester Lab for providing us with a technical workshop. We're very excited for this. Our code of conduct, diversity and inclusion are core values of our chapter. Please do not be a jerk. If anyone feels uncomfortable or feels like anyone is disrespecting them or being a jerk, please let me know and I will escort them out of here and we will take care of it. There we go, yeah. Prashant is unfortunately ill, not here today. Brendan is also not here, but thank you for all of our chapter leaders. Wendy Swarp is here. Go to another slide, is that it? But yeah, thank you for all of our past sponsors and hosts. If anyone, like Marco says, wants to speak at any OWASP meetup, I'm sure you all know where you can find us. We've got our meetup page, but also various other locations in which you can reach out to us. Let us know if you have a company that would like to host or if you would like to come speak at any of our meetups.
Yep.
And some of our past sponsors. Thank you, every sponsor that we've ever had. We appreciate you. Thank you.
Thank you. Now it's my pleasure to introduce the next speaker. So I was talking to him earlier, and you know, there's few people that I can say make an impact in my life, right, in my career, and one of them is Louis. He doesn't need a lot of introduction, but I'm just gonna tell this quick story. So Louis obviously has this company called Pentester Lab, and when I started my career, I didn't know where to start, and happened to be Black Friday, and I saw a deal for Pentester Lab, and I was like, oh, a whole year for like, you know, very cheap, so I signed up for it, and that actually gave me introduction to pen testing and, you know, other stuff. So and fast forward, I don't know, many years later, here I am next to him. So this is a, you know, you never know when you do this type of things, like who you were gonna meet. So Louis, from me and other people that I'm pretty sure you make an impact. Thank you so much.
Thanks.
And you know, that means a lot. And thank you for being here and giving us some wisdom. So thank you, appreciate it. Let's give it a round of applause. Come on.
I'll take a minute. Basically, I thought of telling this. We have CSITES conference in India, so where we help students, you know, by providing stipends where they can't come to conferences and spend money. So Louis is one of the sponsors for CSITES, and he has, you know, sponsored few students to come and learn as part of the CSITES conference. And thanks to Louis, and you know, stage yours, Louis.
I'm already blushing. So if you want to start with the code review and get the code right now, so you can look at it, we're probably going to do the hands-on part at the end because you still have pizza and like, yeah. And we're going to start with me talking a lot because I like talking and I like listening to myself a lot. And like every good French person. So, so today started really well. So an hour before like the pizza were due, we had like a cancellation, like sorry, and that was my answer to the text. Like, why are you telling me that 1 hour? So that's why probably like the food was a bit delayed. I'm very sorry about that, but like yeah, that wasn't nice. Anyway, let's get started. So about me, I'm the founder and CEO of Pentester Lab, which is like you know that already. But I'm used to work as a pen tester. I used to do code review. As like full-time job, like I spent like 1.5 years reading Java code, enterprise Java code, so you can't hurt me. Basically, it's like, yeah. After that, you can't. And I've been an AppSec engineer at like a local host post, Australia Post in Australia, because as you can tell from my accent, I'm from Australia. No, I come from France and moved to Australia, obviously. And I used to be an AppSec engineer as well at Fitbit. That's where I met like some cool people who were around before. And quick one on Pentester Lab, so training platform to learn web hacking, security code review, online at your own pace, or now since like last year, I started doing like live training on code review, and like pretty intense, like 12 hours of code review with me speaking. It's really, really good, but it's really, really intense. So that's what we're gonna do. So I put the hands-on code review at the end, so people who want to stay for the code review, the hands-on part can stay, otherwise like you don't have to stay and wait in the middle of the talk, it's a bit boring. But that's what we're going to do, bit introduction, routing, patterns, CV analysis, one CV I really like, because some people have favorite CVs. Not a lot of people, but some people do. And I'm one of those. So let's get started. So first, probably obvious, but like security code review is really in demand at the moment. Especially if you're working like as an AppSec engineer, as a pen tester, like people, especially in internal team, they want people who can read code and find bugs or find vulnerabilities. So that's really, really in demand. And for multiple reasons, you can like review changes before they are deployed to test or production.
Sorry to
Yeah.
interrupt. Really sorry to interrupt. Everyone's taking pictures. Are you going to be sharing?
Yeah, I'm going to share the slide. Yeah.
Perfect.
Don't worry about interrupting me. I got 3 girls at home, so that's the same thing. You can't hurt me.
Can I get the slides right now from someone so I can copy paste stuff to my computer? For example, the links.
I don't have a way to share them.
No problem.
Sorry, mate. So yeah, as well, like if you want to find new class of vulnerabilities, so let's say you come across something, a protocol, language, or something that no one has done research on. You can't just like use a tool online or something like that. You need to like read the code and understand what that protocol is doing or what is happening. So you need to read code. That's kind of like, I think for a lot of security people, the next superpower to master. Because it's gonna really make the difference between people who can just pen test. It's really hard to pen test already, but if you can pen test and do code review at the same time, I think you're twice as valuable in an enterprise. So even like if you do QA, and it's fun to do code review. I swear. I'm going to show you how. Anyway, so the first point with learning code review is that people have really weird expectations because they like watching talks at conferences or they read like blog posts and they see like this fancy world where people read code and they got vulnerabilities, like magic. You read code, you find vulnerabilities. And then they do the same thing at home, they read code, it doesn't work. You just don't find vulnerabilities. Because the reality of code review is a bit more like me speaking, a lot more chaotic. So it's more like, oh, you read code, then you find nothing, then you like read code, like find a little snippet of code that looks interesting, so you start fuzzing it. You read the documentation, then you read more code, you deploy maybe in a test environment and test a little bit, then you find some weaknesses, things that are interesting security-wise, but not vulnerabilities. And you keep like putting those weaknesses together, you read more code, you go back to reading documentation, you loop, and then you find vulnerabilities. But that's how it happens, at least for me and for a lot of people I know. But people come in with this expectation and you get disappointed really quickly because you keep reading code. It's really hard. It's really hard to like get from code to like vulnerabilities. You need to have like an understanding of what the application is doing and all those things that are really complicated and like it's too hard. You need to like go to that where like you can look at the application, trace the code, maybe debug part of it and see like map the code to like things you see and things like that. So if you come with that in mind, it's going to be a lot less frustrating. Another thing why people hate code review is that, oh, I had a great meme, I forgot to put it in. Damn it. People go from source code, then they run like SAST, grep, AI, whatever they want, except SandGrep because SandGrep is awesome. And then they got a list of things to check. They got like a list of things that like, okay, you got XSS here, you got XSS here, you got SQL injection here. And then they do they check like all these things, and sometimes they get bug, and sometimes they get like false positive, and that's very, 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 very frustrating. And the problem with that as well is that you're not learning much, because you're just like looking at issue coming from a tool and reviewing those. So it's basically your face when you do that. You're crying, you're not happy, it's sad face. What I think how people should do security code review, and I think also what the future of security code review is something that is more like that, especially if you want to find good vulnerabilities. If you want to find low-hanging fruit, that's going to be annoying. That's to find low-hanging fruit. If you want to find good bug, deep bug, bugs that are hard to find, bugs that are going to have a long shelf life if you're like writing exploit and selling exploit, you need to do something more like that. So you still have your source code, but you do the detective work. You like start reviewing the source code, reading the source code actually, and finding things like weaknesses, patterns, maybe even vulnerabilities if you're very lucky. But once you got all these patterns, weaknesses, vulnerabilities, from that, oh, we got an XSS, woo! You use tooling like grep, SEMgrep, SAST, whatever, like AI, to help you scale your effort, to do the heavy lifting, to find even more bugs. And that's a better approach because it's less frustrating, because even if you don't find any bug at that stage, you are still learning. You are still reading source code, you are still understanding how code fits together, how an application is built, what people do to check things, and you get better as a code reviewer. Whereas if you do the other thing, you stay at the same level all the time and you hate it. What's your face if you do that? Happy face. But I'm joking, but that's the reason people hate code review, if they're doing the other thing. They do run grep and then look at the result and they hate it. And the good thing about this approach as well is that it's going to help you identify unknown unknowns. Like things that a tool, or even you as a human, will never think to look at. Never underestimate what developers can come up with when you're looking at source code. Like I was in the plane, I saw someone rewriting JSON as a string. Like instead of using like parsing and unparsing JSON, they were doing it manually with regular expression and concatenating string and things like that. Like things that most people wouldn't do. And that's what you can identify, and most of the time it's pretty good bugs. A question I often get is, should I know the language? Yes. So it's hard if you're not, it's harder, it's going to be harder if you don't know the language, but it's totally fine to start doing code review without fully knowing a language. Especially if you think in terms of pattern and trying to say like, okay, this is a file upload. What would I check as a pen tester or as a security, like if I put my security hat on, what would I check for in this application? And then you try to map those checks inside the source code. So thinking in patterns, thinking in terms of threads, and or if you know something that developers don't know, if you have like it's basic information warfare, like if you know things that other people don't know, you're likely to find bugs. But it's going to be more frustrating. You need to be more resilient if you don't know the language, but that's not a blocker. Should you know to write code? Same thing, it definitely helps. If you know what shortcut a developer will take, if you know what mistakes they may make, it's a lot easier to like pinpoint where the issues are going to be in source code. So you don't need to be a real developer, but having some background in like being able to write small scripts really help. And yeah, again, like for before, like the less you know, the more patient you will have to be. But especially if you're starting, don't let that prevent you from like reading source code. And a big part of that is like thinking in terms of like threat models, saying like, okay, I have this functionality, what can go wrong? And let's check for those things. Let's say, okay, I'm serving a file, what can go wrong? Or maybe they can put ... Are they checking for ... in the file name? Maybe they can use like weird characters in the file name. What will happen? Are they checks in the source code to do that? And things like that. That gives like direction to your review. If you're not really good at threat modeling, there are a lot of methodologies to do threat modeling, but I don't find them amazing. I think the best way to like get better at like finding those things you should check is to like read advisories, read pen test reports. A lot of companies are starting to do their reports online, like QO53 and Trail of Bits. They have like a lot of reports that are really worth reading, like very, very high quality reports. Read bug bounty findings and write-ups. It's fun and it's a good way to learn. Like, okay, and take notes. Like, okay, this is a vulnerability in a file upload. This is what they tried, and that worked. And you take a note of that, and when the next time you review a file upload functionality, you know exactly, oh, I need to check for that because of that bug bounty thing. And my favorite sport or hobby, analyzing CVs. We're going to get into it. That's a lot of fun. Another part of why people hate code review is because they pick targets that are too hard or too easy. And you need to find something that is the right size for your code review skills at that point in time. So it needs to be hard enough and easy enough at the same time. So you don't want something that is too easy Because otherwise, like, it's going to be fun, you're going to love it, but like, you're not learning. You're not going to want to find something that is too hard because you're going to get very frustrated very quickly. Like, you need to build your resilience over time. Like, I was talking to someone who does like a lot of code review, and this person was telling me, like, at the start, they were trying to find a bug, like having targets where they find like a bug a week, and then a bug a month, and then a bug every 6 months. Because you can't start and read the same code for 6 months. And yeah, some people read the same code for 6 months. Like when you talk to people who do like iOS research, like it really exploit that are sold for like a few millions, those people read the same lines of code again and again and again and again. And you need to be mentally prepared and very strong to spend 6 months reading source code and not finding bugs. You can't pull that off like that. You need to build that resilience. And that's a big part of getting better as a code reviewer. So to start, so you can, a good way to start is snippets. You can find like a lot of snippets on the internet. You can just allow some if you want. So the problem with snippets is kind of like, I call that like code review porn. It's like, it's really short, it's good, but like wrong expectation about what code review is going to be. Yeah, I love that. This code, not, or whatever. Then a good stepping stone from that is looking at CVs, looking at actual vulnerabilities that have been published and learn from those. I'm going to get back to it. Then you need to go to small or simple libraries, then bigger and more complex libraries, small application, larger application, and once you're done with larger application, you go to hard targets. Hard targets are things that people are reviewing constantly or regularly, and that are gonna be really, really frustrating. Like I'm talking Apache, OpenSSH, like things that's gonna suck. Like literally, that's gonna be hard. But that's where, like, if you want to do big talks at conference, or if you want to sell exploits, or fix vulnerabilities, that's probably what you want to aim for. Another reason why people hate code review is the way they define success. If you base if you measure success based on the number of vulnerabilities you find, you're going to be frustrated and you're going to hate it pretty quickly. Or even worse, you're going to pick very easy targets to say like, oh, I'm finding a lot of bugs, but they're all going to be the same and they're all going to be rubbish bugs. So you want to find ways to measure success that are not linked to finding or not finding vulnerabilities, because either you get frustrated and you hate it, or either you like you're cheating yourself, kind of like CHEA. Sorry for the accent. So I think measuring success based on those metrics are a bit better, but hard to measure, but a lot better. Like, are you getting better at understanding a code base? Like if you get in front of new code, how is it to like navigate it? If you're looking for something, can you find it quickly? Can you understand like the architecture of the code? This is a great way to measure success, because you're really learning, because that's really hard at the beginning. And if you're getting better at doing that, you're getting better at finding ways. Also, learning ways a check or filter is implemented. Quick story, I spent like a lot of time looking at JWT token. And I spent a lot of time not finding bugs. But trust me, now if I have a JWT implementation in front of me, I'm pretty quick at finding if there's something wrong or if it's worth spending 2 days or 2 months. Because you got this like your code review sense are tingling, kind of like Spider-Man. And also finding small weaknesses, like something that is not vulnerabilities, but that could be improved. And it's really important, especially if you're doing like internal AppSec, to say like, okay, this code is not vulnerable, but we could change that, and this code would be so much better, so much more like anti-fragile kind of way, like better code. So being able to identify those in a source code is really good as well. And that's a way better metrics than just like finding vulnerabilities. Understanding code as well, complex patterns. You have some things like that can be really hard to understand, like bit masking or things like time constant comparisons. The code is not obvious, but if you can identify that, say like, okay, this is why they're doing that, this is what is happening, and I spend like just a few minutes and now I can scan it and say like exactly, oh, the right way to do it or not the right way to do it, or that's almost the right way. Being able to identify that is very valuable, and again, a better matrix. And discovering new patterns of vulnerabilities, regardless of their security implications, say like, okay, or new patterns in code, sorry, not without or with security implication, being able to identify like, okay, they're doing that because of that, that's the reason, that's what they're doing, and this is not security related, but I can scan the code and I don't have to read it carefully for 2 hours. Now we're gonna move to reading code. One of my favorite quotes from this book is not about security, it's just about code reading, but an hour of code reading can save you a minute of reading the documentation. So before you start reading code, and I'm the first to do that, I jump in the source code and start reading, read a bit of documentation before, that always helps to know what you're looking at. Now what to do when you're reading code, you need to notice things. Don't look for bugs, notice things that are unusual. But unusual is hard to quantify when it's your first time, but once you get better at things, you're going to realize like, oh, okay, that's not quite right, that doesn't make sense. When people reinvent the wheel, often when people reinvent the wheel, and outside of crypto, and even in crypto, it's not a good idea. Sketchy code, complexity, like often when developers think they are really smart, they make mistakes. Or when they think they are really smart, someone else will have to maintain the code, not understand it fully, and make mistakes. So complexity is a really good indicator that something is going to go wrong. Like when people do meta programming and things like that, it's going to go wrong. Unchecked return value, and a good thing to check is all the checks in place. Why is there like a regular expression here? What are they trying to prevent? Are they doing it properly? What's the risk here? Because if you're checking something, you know there is something to check. So now you just need to audit the check instead of auditing the full code base. And most of the time it's tiny code, so it's really easy to take care of. And yeah, and also one thing to do is it's really easy. It's easier to review code and say like, are they doing everything right? It's harder to read the code and say like, is something missing? Are they not doing something? And yeah, so think about that as well, like especially like if you look at cross-site request forgery protection, most of the time there's nothing to do if there is no cross-site request forgery protection. So you need to think about like, oh, here there should be a CSRF protection. Also, every time you encounter like new function or method, like you don't know about this method, you don't know about that function, read the code documentation of that function. It's really hard at the start, but you get better at it because you start to know more and more function in a language or method. Look for potential security improvement and issues. In a lot of languages, the documentation tells you like what can go wrong with that function or what can go wrong with that library, so check for those. Read RFC or whatever as well. Fuzz it either with a read eval print loop, like a repo, like IRB, Python or whatever to test the code, or use Docker as well, and keep notes because you're going to find the same function again and again and again, and you don't want to like review the same code, like the same function again and again and again. That's also a great way to like measure success, to say like, oh, okay, am I getting better? Yeah, I know more functions than I used to be, so I'm getting better at reading code. I may not be finding bugs, but I'm getting better. Yeah, also something that a lot of people forget to do is people think programming languages are the same over time. They're not, definitely not. For example, let's look at PHP. Between PHP 5 and PHP 8, so many things have changed. Like, on top of my head, I can give you 10 things that are better in PHP 8 that were compared to PHP 5. Security things, just security things. Like comparison, add slashes, that HTML entities that do encode, that change that encode single quote and things like that. Like they change a lot of things. They remove the /e for peer replace that was evaluating code, like a lot of things. I blogged about it. Look, Pentester Lab, PHP, it's getting better or something like that, and you have a list of all the things. Now let's look at one thing that is important. Routing, basically how an application maps a URL to actual code. I'm sorry, that's very short and very quick, but yeah, it's fine. So basically that's a good part of code review because a lot of people base their code review on that, saying like, okay, we are going to look at everything that is available and just read that code. A lot of people think that the only way to do code review, that's definitely not the only way. That's one of the ways to do code review. There are like 10, at least 10 other ways to do it. And what people do is trying to understand like this mapping between a URL and actual code, and then they decide like if they need to review something and how they will perform the review. Because there are multiple ways to map the URL to actual code, and you can do it based on the file system, but the good old PHP way of doing it, you can do it programmatically and through configuration. I'm not going to cover configuration, that's what struts used to do, and no one wants me to talk about struts. Trust me. Wow, don't cry. So file system based is basically every time you have a file on the web root of the application, it's available externally. So that's basically your good old PHP application. So if you have like a /index.php, if you access /index.php, it's going to go to web root index.php. So you need to read the content of index.php to understand what is happening with the application. And the thing that is interesting is that any file in the web root can potentially be accessed. So if you have a file that is doing something dangerous and is exposed in that web root, you can potentially access it. Another thing that is important is that the extension of the file, so .php, decides if the file is just served, like image, CSS, or if the file is executed and the output of the file is, the output of the execution is provided to you. Because often that decides like what code actually run on the web server. Another way that people do routing routes is around define it programmatically. That's what you're going to see in the PHP application. So every file is potentially available. And where in the Golang application, this is, that's not the real one, but that's an example of routes in Golang. And they are defining programmatically, if you go to /, that's going to be that function. If you go to /register, that's going to be that function, and so on and so on. So that's going to tell you everything you need to list, you need to review. If you want to use that approach to do your review. There are other ways to do it, but that's the way to do it. That's one way to do it. So basically what people do when they use that approach, that strategy, they say like, okay, let's list all of those, and then we're going to review all those functions and try to find vulnerabilities. Where if you're like in PHP, you basically say like, okay, every file that is exposed in that web root directory can be accessed, so we need to review all those files. So that's an example. Yeah, here we have the mapping. If you go to get /, that's going to go to welcome. We also have like, there is none of that in the application you're going to look at, but that's often they use like a middleware, something that is going to be stuck between the application and the function here. So basically all this like function here, after that, after this use, are protected by this middleware. And this middleware will often do like authentication, authorization, CSRF protection, cross-origin resource sharing, and all these things. And yeah, but yeah, and that's our most application. So yeah, if you access SendMail, you may not see any authorization or authentication because that's not going to be here, but it's going to be in the middleware here. That's why sometimes it's a bit weird to look at. Another thing that is really important when you look at code review, and especially if you want to get better at code review across multiple languages, is think in terms of patterns. Abstract the syntax of the language and look at patterns of bad code. So when I do training, what I do is I split the training in two parts, or like a lot of parts. I got patterns and gotchas. Basically, patterns are something that is going to work across most languages, and gotchas are something that is only going to work in a few languages. Like regular expression in Ruby are pretty weird. That's a gotcha because that's only in Ruby. I don't know. Golang file path.clean is the naming is terrible because that doesn't remove directory traversal, but just that just does canonicalization. But here we're going to look at patterns. Because a lot of issues are completely independent of the programming language, so make sure you focus on the pattern, not on the language. One of my favorite patterns, and I've got like many, is this one, is you filter for malicious values, then you modify the value to work for whatever reason, and then finally you use the value you just modified. And the one thing, if you see that pattern, you need to keep in your head is that, can we introduce some of the filtered values back using the modification? It's hard to understand like that, but it's a lot easier with code. So that's, I don't have the CD, but that's a bug in JSP Wiki, where basically you have a file upload in Java, because everyone loves Java. Java is lava. Validate finance, so we're trying to prevent people from uploading files with .jsp or .jspf, because that may mean code execution. So what we do, we check the file name, we clean it up a bit. If it's null, we return an exception. We trim it, and if it's empty, we return an exception because we don't want an empty file name. Then we do a split based on this regular expression, simplify it, and then we get the last part, and that's going to give us the last part of the path. So we got a full path, and we get just the file name. So a good indicator, if you were to do code review, is that here you have function in Java to do that. So if someone does that, they're not really good at Java, or they're not great at Java, because they should be using the function from Java. They should not be reinventing the wheel. Then they do find and tree. Then we have this check. We do some good thing. We don't want the file name to end with .jsp, and we don't want the file name to end with .jspf, because those are dangerous extensions. Really good. Then what we do is, maybe there was a problem with some characters that broke the application or something like that, but we remove all these bad characters because they're really, really bad. So we don't want hash, we don't want quote, double quote, we don't want semicolon and so on. So what we're doing is filtering, really good, but then we're modifying the data. And so if your file name is something like that, hack.jsp with a hash, that's not going to match here, because .jsp doesn't end with .jspf or JSP. But here, the hash is going to be removed. And that's a pattern that happens a lot. So every time you see someone filtering and then modifying, trouble. Another example is, again, some Java. So that's, it's not a CV, it's a GitHub advisory. So what they were trying to do is prevent cross-site scripting. So to do that, they had a name and they needed to replace a lot of bad characters, replacing space, %, opening curly bracket, closing curly brackets, comma, plus, and replacing it either by nothing or underscore. Then there were HTML encoding that value to remove even like to encode less than, greater than, and so on. And then finally they were doing like NFC normalization. So for like Unicode characters, we wanted to kill those as well. I put a note. So what they're doing is filtering all the bad stuff, or encoding all the bad stuff, and then modify it. And through the normalization, through that modification, you can reintroduce some of the characters that were either filtered or that were encoded. And you end up again with cross-site scripting. Again, because the pattern is bad. So how they fixed it, it's always interesting to look at how people fix bugs. They just swap things. They did first the normalization, and then they did all the filtering. And this way, as far as I can tell, the code was no longer vulnerable to cross-site scripting. So really, really, really good pattern to look for. Another pattern that I really like is matching is really hard. So first, people suck at regular expression. Like everyone is bad at regular expression, me included. Too hard. And the thing that is beautiful with regular expression, especially if you're talking about host name or domain and things like that, is that the dot in a regular expression means any character. The dot is a separator in like a path or in a host name and between the domain and everything. So people, what they put like, oh, pentesterlab.com, and they forget to escape the dot. So the .com means any character, com. And so the regular expression is wrong. What also a lot of people are bad at is ends with, contain, starts with, they are exactly the same thing. Like a lot of people don't really think that through and like, okay, that's probably good enough. Because if they do like the happy path, it works. But when you're attacking the application, people are not so happy. An example is validating that this email address contains @libcurl.so, because you have the domain @libcurl.so, it's your enterprise domain. I actually own that domain, believe it or not. Very cool. If you know what libcurl is. So basically here you can bypass that using libcurl.so.pentestler.com, because again, it's a contains and instead of being ends with. And when people use ends with, they sometimes forget the here. So instead of libcurl.so, you can libcurl.so, you can put @libcurl.so, because you forgot the here. So you can put your own domain again. Also, some people sometimes they don't. So first, they don't use the right function, but also they don't match the right value. This is from a real CV, but I forgot the number. But basically, you have this middleware that checks that you have, so that's code based on the CV that I rewrote to teach people that issue. That's not the real code, but it's based on the real CV. Basically, you need to be either admin or access the health endpoint. If you access the health endpoint, you have access to the health endpoint, and you don't need to be logged in. That's for monitoring. If you access any other endpoint, you need to be logged in as admin, because they are like getting JWT token, parsing it, verifying that it's valid, verifying that there is no error, verifying that it's valid, and then they check like, okay, r.url.string, so in the URL, does this contain health, or is the user in the JWT admin? And if that doesn't happen, they say like, okay, you don't have access to this resource. What is happening here is that instead of using, do I have the code? Yeah. Instead, here they're doing a string contains, which is not great, because you kind of want the path to ends with or starts with health, but also they are matching on rurl.string, which is the full URL, including the parameters. So imagine you have an endpoint with /API/v1/health. You can just, and you have access to it, but what you can do is go to /API v1/super secret ?health. And you go to the super secret endpoint because that URL, the full URL, contains health. And so people need, you need to be very careful, are they applying that matching to the right thing? And can I find way around it? Because that's tiny mistake, but that's pretty good bug, if you ask me. Another one is reinventing the wheel. Never a good idea, especially in crypto, but in other places as well. If people are rewriting their own uppercase, lowercase, or split or cut, that's a good sign that it's going to be wrong. String manipulation seems like something very, very simple. It's not. Like uppercase seems really simple, very, very hard. I wouldn't write my own uppercase. Because uppercase of Louis is really simple. But uppercase of Louis, where the I is a Turkish I, not very so simple. Like Unicode character, if you include Unicode characters, everything starts to be a lot harder. Let's say that. And people do a lot of mistakes because of that. And same for file manipulation, getting the extension from a file name, not that simple. There are a lot of corner cases that people may not think of, and it's really easy to audit as well. You spot the difference. You take the implementation from the language, the implementation from the person, you compare them, are they doing the same thing? And then you find corner cases and you can often exploit them. And yeah, but really really hard to get it right so people get it wrong. I got an example of reinventing the wheel, a bit more complicated, but that's an amazing bug I found. That's why it's amazing. In Play, so Play is kind of a Java version of Ruby on Rails. So they try to rewrite Ruby on Rails in Java and Scala. If you want to find good bugs, audit some Scala. It's a pain to read, but so many mistakes. So basically, that's what the code looks like. So they are going from a session in memory to a cookie, and back from a cookie to a session in memory. Story is, I had a long commute to the city in Melbourne, and one day I was really bored, very, very bored. And I decided to review 6 or 7 implementations of session management in Java. They all look the same, except one. And that's when you know as a code reviewer, okay, they're all the same, this one is different, that's going to be the one with the bugs. And I found this bug in the train. So basically what they're doing is they're reinventing a serializer. They're looping through all the elements in the session and then writing them as a string. and then in another part of the code they do the opposite. But they're reinventing a serializer. Basically, they should be using JSON, they should be using whatever they want, but don't write your own stuff, because it's hard to get it right. So if you have in your, if you have like session key, a session with key 1, value 1, key 2, value 2, you can end up with null byte, key 1, colon, value 2, value 1, null byte, key 2, colon, value 2, null byte. That's what this loop is doing, going from like some data in memory to a big string that they can send as a cookie. Yeah, and sorry, I went a bit fast, but obviously you don't want someone to just change the value from Louis to admin or something like that. So the whole thing is signed. So you can't just change the value, flip like admin Louis or something like that, because there is some crypto, and you can't write crypto because it's, yeah, from memory it was an HMAC one, like HMAC of SHA-1, but yeah. So if your username is Louis and your email is louis@pentesolab.com, that's when you're going to end up with Louis, null byte, email, louis@pentesolab.com, null byte. Now that's the other way. When you receive a session that is signed, how we go from that session, that big string, to a session in memory. So first they create a regular expression to match the elements. And again, they're reinventing a parser this time. They should like parse serializer and deserializer. So what they do is first they get the cookie, then they search for a dash that is used as a separator between the data and the signature. And from that they get two values, the signature and the data. They sign the data with the same secret, but we don't have access to as an attacker. And they compare the signature with the signature they just computed. If it's exactly the same, you're good, you get in. If it's not the same, you try to modify something or you try to modify the signature. You're a bad person, you're not getting in. And then what they do is they URL decode the data, not really cover that part, but then what they do is they use that regular expression to go through the long string and map, look through every element and put that in the session. Session here is a big hash map of string. So basically what we do is, so yeah, they look through the element in the session, but it's not great, again, they shouldn't do that. They should use a serializer. But what happens is that if we have this session, this signed cookie with null byte, key 1, value 1, null byte, key 2, value 2, null byte, that's going to be split in two parts. And that's going to call session.put key 1 and value 1, session.put key 2, value 2. And that's going to end up in your session. So you're going to be user Louis and the email louis@pentesolab.com. Now, if you look at this put function, what they do is they check that, so you have the key, so the name of the value and the actual value. They check that the key contains a semicolon, because at one point in time, that probably broke something in the past. So they throw an exception if that happens. Then they check if the value is null. If it's null, they remove it from the internal structure as data. Otherwise, they just put the key and value in that hash map. So a dictionary of like key value, key value, key value. So here, when I was reading the code, what really struck me is that there is no check on the value. So you can't put a colon in the key, but you can put a colon and a null byte in the value. And as a client, we most likely only have access to the value. So we can inject, because that's most likely our username or something like that. So let's wrap it up. Username is user controlled. We are a good person because we are Louis. Louis is always a good person in those stories. Trust me. Like in life. You heard it before. So we do username Louis. That's going to end up with session.put username Louis. And that's going to end up with this null byte, username colon Louis null byte. Now, we're not so nice Louis. We like a bit Louis being fun. We put our username as Louis null byte, username colon admin. What our current username is username Louis null byte, username admin. That's going to end up with session.put username Louis null byte, username colon admin. And that's our cookie. We have the signature that I removed for space, but basically we are the user with that long username right now. That's really interesting. But then we visit the page again, and the application needs to parse our super cookie. So yeah, right now we're a good person, but when we go back to the application, when it's doing that looping through all the elements and passing the data, we end up with 2 elements because we have 2 null bytes here. And what the code does is username called Louis null byte, so it's doing like session.put username Louis, and then it goes to the next element because that matches again, and it's going to do get username colon admin null byte, and it's going to do session.put username admin. And since it's a dictionary, like a hash map, that's going to override the previous value, and we become admin in the application. I was pretty proud when I found this one. I cried a little. Yeah. So if you want to find a lot of good bugs, what is really important to do is CV analysis. If you want to get better at that thing, like CV analysis is like really key. Kind of like chess player, they do like they focus on part of the game to get better, like end game or middle game, like or openings, like same thing. Like that's a version of that, like deliberate practice for code reviewer, in my opinion. You're going to learn new patterns. You're going to learn how people fix issues. Also, you're going to find good bugs because sometimes people fix bugs and they're not really good at fixing bugs. And yeah, trust me, I got like one, but I'm still waiting for them to fix. I reported it like 8 months ago. And yeah. And so how do you do that? First, you read the advisory very carefully because all the time you're going to spend reading the advisory is going to save you time later on. You clone the repository. You find the tag for the vulnerable and fixed version. They are not necessarily the same, so the Git tag, they're not necessarily the same as the version you find in the advisory. Then you extract a patch or a diff, you analyze the patch and the diff, and you say like, okay, what does the vulnerable code look like, what does the fix look like, and is this properly fixed? And also, look around that code. Most of the time, codes are located in the same spot in code bases. Like, kind of like I call that a swarm. It's like either like the code hasn't been touched in years because it's in that part of the application, or it's like the same person who wrote the same bad code in one place, whatever. Like, if there's a bug somewhere in the code, it's worth spending time around it because you're going to find more bugs. And so one thing when you get the diff is often people think that, okay, people writing code, there's a bug coming, someone reports a vulnerability, let's stop everything and fix it. That's not really the reality of things. So this is a number of digits, on like 600 CV, around 600 CV I had on my laptop recently. So basically, most of the fixes will be between 3 digits and 5 digits, as in between 100 and 101 million lines of code. Check. Like just between 2 versions. So because what is happening is if you're very lucky, you're in that case. So there is a vulnerable version, someone is writing code to work on this version, then there is a bug and they stop everything and they patch the version. You're really lucky, like that's the best you can write. But most of the time people are going to write code before or after, especially if the project is very, very busy with a lot of developers and things like that. So that's why you're going to end up with like 1 million line of code to read. And the trick is not to read the 1 million code, it's just like to find keywords and try to work it out. But you're going to end up with like big patches. Like 100,000 lines of diff is very common. And also, some developers are jerks. When they're fixing bugs, they like decide to relint the full code base or like change the documentation around or rename files and just making it harder to reverse the patch for attackers. And that's a pain. And yeah, so let's look at actual methodology. So I took like a little CV in Go 0, whatever that is. Authorization bypass in Go, critical, so probably interesting. We can see that in the advisory we don't have a patch version. But what we're going to do is clean the, git clone the repository. Go in the repository, list all the tags, and try to find the one that matches. Based on that, it seems like less than 144 is vulnerable, like strictly less. So I did that, which obviously did not work because that's not the right version. Sometimes advisories are wrong, so you need to know that. I know the bug was from the advisory linked to cores, so I break for cores to find like if at least there is a match. So then I moved to the next version, 151, and then I break for cores. and I get some matches. So I'm like, okay, this is a bug about cause. In that diff, I got some matches for something related to cause. I find two files that get modified, handlers.go and handlers_test.go. So that's probably what I'm looking at, like handlers.go. So from that, in one command, you do like a git diff, vulnerable version, 3 dots, fixed version of the file name, and you got all the change with what happened. So again, like often when people fix bugs, they decide to revisit the code. So here this developer decided to rename variables. We change O to allow, and so that's really hard to do, a lot of change, but it comes down to that, those 2 lines. What we are trying to do with cause, with cross-origin resource sharing, is when you do that, you need to match a host name, and most programming languages don't provide a good way to match host names. They don't have a function to say like, this host name is part of this domain. So people need to write their own version, and they get it wrong. So what they were doing is do like, okay, does the origin, does the O, like the origin, the allowed value, as the origin that the user just passed, and with a suffix, as suffix. So basically, they were checking that if the origin provided by the attacker ends with, for example, pentestallab.com. Thinking like, okay, we want to allow pentestallab.com and any subdomain of pentestallab.com. That's why they were not using a straight match. Then they moved to use origin as suffix, same thing, but they just added a dot. So what I ended up doing is that instead of matching pentestallab.com, they were doing .pentestallab.com. And that's what the issue was, the dot was missing. So yeah, so they actually allowed all hostname ending with the origin that was allowed. So you just had to buy like the right domain to bypass the protection. And people do that, get that wrong all the time. So yeah, that's pentestallab.com. You could buy like hack by pentestallab.com, unless someone bought it as a joke already, but it should still be available. Once you're done that work, I'm pretty happy because you learned something new. What I find extremely valuable is to save your work, keep notes. So what I usually do is like git show the version and the file I like, and I call that like handlers.go-before, because that was the name of the file. And then I do the next version, and I do next version handlers.go-after. This way, I have the vulnerable code and how they fixed it. And that's really handy to learn, because you're like building up like a knowledge database of all the bad patterns and all the bad code you can find. And since I like sharing, I'm going to talk to you about the first CVE I ever reviewed. Probably. I ever wrote about it.
I was curious, just before you move on to the next topic, I know in a lot of those GitHub security advisories, they link to a specific commit in the repo. Do you ever look at that to like check to see what they changed?
Yeah, a lot. I looked at, so they're not always accurate, but I looked at those a lot. The thing as well as I look a lot at Apache projects, like the Apache Foundation, and you don't have that because they don't do that in GitHub. That's a nightmare. Apache security, like.
Yeah, I know they don't always.
But like GitHub was really smart in the way they implemented their vulnerability disclosure functionality. Is that they automatically use, when you generate a report on GitHub for vulnerability, and then it got accepted by the vendor, like the open source project, and then they got a CVE, or you can request a CVE through their interface, and then all of that becomes a JSON file in their GitHub advisory repository, and you can look for those and like. Let me check. I think I got. And the feedback tool in sorry. So the GitHub. And the feedback to that is there's something named GitHub Advisory Database where you can pick per language and all. That's amazing. That's a good way to do like code review of Git projects that are hosted on GitHub.
So quick question regarding that. So normally, is it always a 1:1? Like you found something and they patched it, but there could be other fixes in the interim, which could also impact your finding as well. So then, how does one go about in those situations?
So I don't know if they do it on GitHub, but like you need to review like a lot of things and look at like often it's over multiple commits because the first one has a patch and then people realize that it's missing a lot of things. So you need to like get multiple like look through multiple commits. What I usually do is I get the diff between the vulnerable and the patch version, so I get all the changes. So I got like multiple commits compressed in one change.
So in conjunction with that one and the image you showed where it was one bug but 3 people, is it also possible that there are multiple bugs which are related to each other and not just one bug which is being flown, but there are multiple iterated ones which could also impact?
Yeah, like everything is possible. Trust me, like it's so this. This was really very much like the happy path. Like I got like nightmare of that. Like no, not nightmare, but like sometimes it's really hard. Sometimes they rewrote the full thing. Sometimes it's multiple commits. Sometimes it's fixed across multiple versions because the fix is incomplete and they published a version, then go to another version. It's like this is very much a happy path. Yeah. And yeah. So that's amazing. So I really like something about code review and web application is security engineering. Basically breaking crypto without being able to do any mathematics. And I really like that. So that's another example of that. So that was in WordPress in 2008. To give you an idea that I have spent too much in that industry, too much time. So that was basically when you were logging in WordPress, you had either like your normal session or you had like a remember me cookie. A cookie that will last longer, so even if your session expired, you will still be logged in. And that's often like a good target because people need to reinvent the wheel to do like session management, and if they reinvent the wheel, they're gonna get it wrong. So that's the code for that. So basically, first, they're trying to retrieve the value from the cookies. So like, okay, is it empty? We're going to try to get the cookie from the actual server if no cookie was provided. Then that this explode to split the cookie in 3 variables: username, expiration, and HMAC. So HMAC is a signature that protects the cookie. Then we created that other variable. For some reason, if people were sending a post request or doing AJAX, we were adding some time to the expiry to make sure that the remember me cookie was valid for a little bit longer, because back in those days, internet was slow, I guess. And then they were checking if the cookie was expired, because you don't want to sign something without expiration. Like you want to put like an end date on anything you sign. So that's really good code. Then they were computing this key that was used to sign the cookie, using the concatenation of the username and the expiration. WP hash uses like some internal key, an internal secret key, and basically we can't guess that key. We can't break the crypto is sound. Oh, the key is safe, let's say that, the crypto is not sound. And then they were doing an HMAC of the concatenation of the username and the expiration with the key that we can't guess, using MD5. Not great, but HMAC MD5 is not too bad even today. MD5 on its own is bad, but HMAC, hash HMAC of MD5 is not that bad. And especially at the time, like 2008, like long time ago. And if that HMAC is $hash they just computed was different to the HMAC because from the signature, someone did something naughty, so we return false. So, and then we get the username based on that username from the database. If there is a user, if there's no user, we return false. Otherwise, we return the user ID. This code, like honestly, looks pretty good. Like really, really good. Like really, really good. Until someone way smarter than me looked at it. So basically, you're logged in as admin, and you want this remember me cookie. So admin and exploration, so Unix timestamp, time since the 1st of January 1970. And that's your cookie with a signed value here. You can't mess with that. If you modify anything here, that's going to break the crypto. But actually, that should be a pipe, that shouldn't be like a column. But yeah. So you end up with, when you do the explode, you end up with admin, this expiry, and this signature. And if you modify anything, again, game over. Then we compute the signature, and we compare it with the value. Now, I'm another user, let's say admin1. I got similar expiration and another signature, and I can't break that signature because crypto. But that's what's happening. Admin1, this Unix timestamp, and this signature. And again, I'm computing the HMAC of admin1 and the expiry just by concatenating them together. That's when it gets good. Now, let's say I'm logged in as admin1. That's my expiry, that's my signature. I can't change anything, right? Because everything is signed. But what I can do, because of that line here, I can shuffle things around. And I can move the one from admin1 to the expiry. The expiry is even bigger, so even more in the future. So that cookie is going to be valid for a long time. And when I'm exploding that cookie, I get the value here, admin11, and the expiry and the signature. And I'm going to compute an HMAC of admin with that long expiry, long time in the future, and compare it with the same cookie, admin1, with that expiry I had here. So they're basically exactly the same thing. So every time you sign data, put separators between the values. Because that's what the bug is that you can shuffle things around and yeah.
So you would have to sign up as the username admin.
One. Admin1.
Admin.
Admin1. Just admin1 and move that one to the expiry.
How is the one moved to the expiry?
Or you just like you get the cookie in Burp or in your like browser, like a application, like a cookie store. You take the one and move it from one side to the other side of the column. That's amazing attack, super simple to do. Like, and the code looks pretty good. Really like. And how they fixed it, they just added like a separator between the username and the expiry. So this way, since you can't have a pipe in the username in WordPress, you can't do things like moving the one from one side or the other and do things like that. That's such a clever bug. That's why you should look at series. Yeah. And lesson learned, always include a delimiter between values when signing data. Very, very, very important. I think you will believe me now. So before we move to the thing, conclusion. So when doing security work, pen test, code review, I always try to keep in mind this picture. I find it like the best motivation ever because most of the time it feels like I feel like I'm this person. You're giving up too early and you're almost there and you stop just so close to the diamonds and it's just like ah. And often you just like take a walk, I don't know, go for a sleep, go take a nap or whatever, and come back to the code, come back to the web application, and you're gonna break that little thing and find the diamond. So you don't, I know like going to pen test or review, you don't have all the time in the world, but sometimes it's worth like taking a break and coming back the next day or an hour later and keep going for like, when you're like, okay, I'm giving up, I found everything, like put like 5 more hours, 10 more hours, 2 more days or something like that, and you're gonna be amazed at how many bugs you're gonna find. Because most people stop at the exact same time, I think. Good quote from my friend Silvio. All important targets require substantial initial investment before discovering and consistently discovering vulnerabilities. Really good researcher, but a bit of hope for the end. If you create software, you may have as many CV as you want, and don't forget to add them to your resume. So if you're a developer, being a researcher is a lot easier. If you want to keep in touch, I'm pretty much on every platform, website, that's the live training, email. If you like don't have time to do the code review tonight or you want to get home, which I completely understand, Email me if you have questions about the code or like want to brainstorm about it. I very much like talking about code review, as you can probably tell. And yeah, LinkedIn, whatever. Like you can be like LinkedIn buddy, or like whatever you feel like. And yeah, and don't hesitate. And conclusion: practice makes perfect. It's hard. It's a hard skill to learn. It takes time, a lot of time. There are also people think there are no bugs to be found. Like, trust me, plenty of bugs. So many bugs. Especially hard bugs. Like, low-hanging fruits are getting harder to find because automation, AI, people running grep, but hard bugs like the WordPress one, you can't find that using automation. Like, nah, you need to like bang your head against the screen for a few hours before you find this kind of bug. And even like that doesn't work all the time, trust me. And yeah. So now we can move to the hands-on part. There's two applications, Golang and PHP. It's a really small web application, like really like you can log in, you can register, and then you can upload files. And the applications try to prevent you from uploading files that are not PDFs. So like really small application, plenty of bugs, like it's, yeah, kind of like shooting fishes in a barrel, like it's, yeah. So if you want, otherwise, if you have any question or, yeah, I think that's about it from, yeah, that's the bigger version. That's basically what the application is. Thanks a lot for your time, and yeah, thanks.
Before he leaves, we're gonna give up, Sam Kerr's gonna give away 3 books. So let me call Amanda, but basically it's from Tanya Yanka. So hold on, but
Perfect. I brought too many stickers, too many keyrings, too many t-shirts, too many socks, and I don't want to bring them back to Australia.
just come.
So don't hesitate if you want like a pen. Oh, like.
Or you can give away a T-shirt as well.
I got too many to give away. I can give them like 2. But that's very nerdy sense of humor, but like, yeah. So don't hesitate if you want one, just come. Yeah. Otherwise, get cracking on the source code. It's pretty fun. Or do it like after, or like have pizza network or whatever. Like,
Okay. So,
I'm not your boss.
all right. So you wanna go in front?
Wonderful. Sounds good. Okay. Perfect. Oh, it's okay. We can just do it this way. So I'm going to pull up the names in live time. But thank you to everyone who signed up to our newsletter and entered our giveaway. The first one.
Oh, he's gone.
Is he up?
Next one.
Next one.
You snooze, you lose.
That's what happened. When you come only to eat the pizza. That's it. In the end, you miss the good stuff. Always
Tyler
happens.
Hawkins. Tyler
All right.
Hawkins. Woo!
Thank you.
There we go. Perfect. Thank you so much.
Good.
There we go. Okay. Awesome. Ed Martinez.
All right. Yeah. Congrats.
Okay, and the last one. Oh, it went back to Tyler. Okay, we're gonna spin again.
I got 2 books.
Code.
That's a sign.
It seems like today's your day.
Jimmy Lee. Jimmy.
Jimmy.
Jimmy
You
was
leave
with
as
Food
well?
for All.
Okay, 3 times the turn.
Yeah.
There it is.
There you go, Katie Tucker.
All right, Katie. Woo!
Wonderful. Well, congratulations, everyone. Thank you.
Thank you.
I gotta read the whole thing.
Any question as well?
Also, the recording is gonna be on our Pacific Hackers YouTube channel. So if you go to youtube.com/Pacific Hackers, it's gonna be there.
Is it possible to add the slides on the description? If you're
I can send it to you. I need to upload them, but yeah.
I have a question. So you mentioned at the start you mentioned that some of the code, like you either start freely or you start using the SaaS tools to assist you, right? But so normally I've seen like many times some of the bugs are squashed because of the overlying framework that you're using. So how do we know if we start from the code whether this code is reachable or not from the web application? Like we do find those exercises that they are definitely, it's not secure code, but then will this actually come into effect or not?
So very much depend on your goals and on the code base and the framework, and like sometimes, for example, I just edit code for fun to learn, and even with, like my goal is not necessarily to find vulnerable, like exploitable bugs, and sometimes just makes the application less fragile. But sometimes, yeah, you find really good bugs, and the code is not reachable anymore, and that's why people tend to use the routes to say, like, okay, what is actually reachable? Because they mostly care of being efficient, which I completely understand. I very much care about learning, and I care about finding bugs across a lot of code bases, which not many people care. Like, if I find a bug in a code base that is not exploitable, but from that I can have a pattern that can apply to other code bases. That's a big learning, and then I'm going to find bugs. When I was working at NAPSEC, what I was doing is git clone the full enterprise code, review code, find a cool pattern, then grep or some grep over like the whole company code base, and then you find bugs.
Is it possible, like you start, like you mentioned three, four things. One, you mentioned documentation.
Yeah.
The other thing you mentioned was the SaaS tools. The third thing was the free research, like just from starting the code.
Yeah.
Would you think that a fourth addition would be dynamically testing the application? So let's say you start with a book and you find an endpoint. You think it's reachable, that's for sure.
Yeah.
Now you try to find that in the code where that is. And because there is a possibility of something, but from one bug you are now escalating to 10 different kinds of bugs, because you know this is reachable. So would you suggest, like, think like, is that also a good way to approach?
So what you can do is, if you do that, is enable tracing on the application. This way you can trace the code everywhere. You can see all the paths, and you can. And another way that I really like to do is debugging. So in Python, Ruby, and all those like scripting languages, it's like you edit the code, put like one line to say like debugger, and then you like put on that endpoint and like, okay, this is where we're starting to work, and then you can. So you send your request with repeater or curl or whatever. You have your debugger like popping up. You start debugging, go through, then you say like, okay, let's try again with another curl request, and then you keep doing that, and that's very, very much. And tracing as well, like to find this first step where like, okay, what is happening when I'm sending that request? Tracing is very noisy because you get all the code stack of everything, but at least it helps you like saying like, okay, this is where it's going in the code, and like, especially like with a lot of libraries and stuff like that, this is where it's going. And if you do that in a Docker container, because that's way it's Docker containers are small images, so it's really easy to grep over all the file system, and your main computer will not be like riddled with like shitty dependencies after 2 months of doing that.
Thank you.
Good question.
Yeah. One other question. So some development teams, they they want to do like shipment and all that. So they let developers do create unit tests.
Yep.
And I was wondering like how do unit tests ties into this entire effort? Is it related, unrelated, unnecessary?
It's amazing. So unit tests are really important in a lot, at many levels. So first, basically, they allow people to patch code. If you don't have unit tests, it's hard to change code because it's going to break. If you have unit tests, you have a level of confidence that you can apply patches, you can fix code. So if you don't have integration tests, unit tests, or tests in general, you pretty much you don't even have a security problem yet, or you just have like a code quality problem. So that's really, really important to do that. Secondly, when you're patching bugs, you need to have test cases to make sure the application still works, but also that the bug is not variable and will never be reintroduced in the future. And also, you can use unit tests as a code reviewer. So like, okay, what are they doing in their unit tests? Oh, we're checking for that pretty well. Probably I don't need to read that code. Checking for that pretty well. Probably I don't need to read that code and do that as well. So the more, no, not the more unit tests you have, but the more coverage you have in your test, the better for security and for code quality in like that. Very important. Yeah.
So if I find that vulnerability using this way of reviewing code, and then I patch that vulnerability, I can test if the code still has a vulnerability by implementing a test,
Yeah.
however complicated it may be.
Exactly. Otherwise, I think there's still drinks and pizza left as well.
I mean, how much time do you spend reviewing code before the fight things?
Is too much a good answer. No, on a good week, I'll probably look at between 50 and 60 CVs. But sometimes it's like 2 minutes, like just like, that's boring, I don't care. Sometimes it's a day, so I don't look at that many, but yeah. I need that for pentester lab to teach content, to create content because I need to find bugs or things that are interesting to teach. And since I'm using CV to teach people, I need really good CVs, as in they need to be self-contained. I can't teach people if the bug is in 3,000 places. So I need something that is self-contained, that has something interesting to teach people, either because the exploit is interesting or the vulnerability is interesting. So I need to look at probably 50, 60 bugs, find a few, 3 or 4 good bugs, I think, that are worth teaching people.
I've seen previous presentations of yours many years ago. I think you had like quite a complicated setup to monitor the GitHub repos.
Yeah.
And bugs.
No, I'm not doing that anymore. So I need to bring it back actually, but like, yeah, I'm very busy unfortunately. So I built like many things. So I built, I like to write code. So I did a talk where I was doing, basically, it was 12 years, no, 10 years ago, 12 years ago, doing like classification when like it was still called like machine learning, not AI. I was doing like a classification of commit to say like, okay, are they worth reviewing or not reviewing? Using like a basic, like closest neighbors, I think, and kernel method. Yeah, so I was doing that like 12 years ago to be like, okay, this commit is interesting, this commit is not interesting, doing like, based on multiple features, like function names, number of function names, number of if statement added, size of the patch, and based on that, trying to find like vulnerable code. The problem, what was hard at the time is that most, it was good at detecting vulnerability being fixed, but it wasn't good at finding new bugs being introduced, because in most code bases, vulnerabilities are there very, very early, and either they're not exploitable at that point in time, or like new vulnerabilities, it's more rare to see new vulnerability being introduced as opposed to new old vulnerability being found. Another thing I did, another tool I did like as an AppSec person is I created this tool named Git Stitches, because snitches, Git Stitches. I got a great sense of humor. And basically it was like monitoring like enterprise Git commits for finding like easy bugs, like things you can grab, finding people using like function we don't want them to use, like MD5, not a good idea most of the time. Finding names of new developers to onboard them inside in the security training, saying, oh, you're new, I never seen your email address before. Or, oh, you knew you're actually committing with your personal email address. And yeah, so, and like putting them through training and things like that, or just contacting them, like if you find something, if you see something, say something and contact us and things like that. There's a lot of cool automation you can do around source code. And also, if you do that, I have access to the full code of the enterprise. So I could just grab over like all the code base and find a bad pattern and say like, okay, apply it to everything. But that was like, I don't know, 7, 8 years ago, 10 years ago for the first version and 8 years for the second one. And I think it forced me to write it in Python the second time, which is, I really don't like Python, I don't know, it just doesn't work in my brain.
So, one thing you mentioned about WordPress.
Yeah.
You mentioned about PHP and all these things. So these things are things you can install by yourself, and you can find the older versions. You can play around with it. Everything is possible. Nowadays, with all the software as a service, where the platform is the one decides they have a new version, they can update it overnight. You don't have control over what is installed and how it's working and everything. So, what are your thoughts on that? Like, how do you test those? Let's say you're using some Adobe Commerce version, and 2 days later they just auto-update it and it's updated across everyone. If it's not on premise and if it's on cloud, then how do you go about those kind of things?
So if you have this kind of environment, you probably want to move away from code review to an extent, because the problem is that you can only check what you control, and like, but that's also like something like people have trouble understanding that if you don't touch software, like code, the software still changes. Like TLS certificate expire, API change and things like that. So even if you don't touch code, and that's what one of my tools was doing that as well, detecting a repo that weren't worked on or were very active. Because you can, very active, we need to talk to them as security person, but not worked on. This code hasn't been changed, and maybe like some things are changing under the hood, and we don't know about that, and no one is checking for those. But yeah, if you have this kind of environment, you probably want to like have like integration tests, like attacking the application in real time and stuff. Yeah, and trying to detect what changes when when the vendor is changing something on the yeah.
Also, like, what about dead code? Like, when you do source code, there could be underlying dead code which is never used.
Yeah.
So you don't even know if that's an undocumented feature or that's dead code.
Yeah,
So
that happens a lot. Like people don't clean up their mess, but sometimes I see that as a learning lesson. Like and especially like if you're like thinking of learning and measuring success, finding a bug in dead code is better than not finding bugs. And it's frustrating when you want to like find bug in your application because that's your job, or you're like doing bug bounty, or you're selling exploit. That's very annoying. But if you're like a learner and trying to get better, that's a really good signal that you're doing great. But yeah, it's frustrating, and that's why most people do like routes-based review, because they don't want to look at the dead code because they want to find vulnerabilities. Mm-hmm.
Black box successfully, how valuable would the JavaScript be?
As in like client-side JavaScript? Yeah, like it's pretty good. Like I like server-side bugs. I like shells. But now, like you can find really cool bugs in JavaScript, like cross-origin, like cross-message and things like that, and API endpoints as well that are like hidden and things like that. So it's always worth looking at front-end code. But yeah, it's rare that you get shelled from those, so I don't like them as much. Also, browsers are way too complicated. But any code is worth learning, I think. I'm really passionate about source code. Anyone found any bug in the? Yeah.
I found 2, and I think I found a third one. Some low-hanging fruit. I'll start with the most obvious one, I think. And you can tell me if I'm wrong about any of these. In JWT.php, there appears to be a hard-coded value.
Yep.
Don't hack me, bro.
Yep.
As a secret value for the signature function.
Yep. Exactly. That's one of those. Yeah.
Okay. Another thing I noticed in
user.php under add file. One of the specifications, it seems to be that you can only upload PHP files. PDF files. Yeah, my bad. So I looked at the parsing, and it looks like when a file is uploaded, it does a regex match with the pattern .pdf, and the dot is escaped properly.
Yep.
It does an regex match of .pdf on the file. But I noticed it also doesn't specify that PDF is at the end of the file.
Yep.
So I figure you could do maybe file.pdf.exe or something.
Yep. What's yeah? What's the code we're talking about?
Yeah,
so
that's
that's very common with a regular expression is people forget to put like a end of the line or start of the line. So here that's exactly what it's happening. There is a regular expression to check if the file is a PDF file, and they check that there is .pdf in the file, but you can upload a file that is .pdf.php, and you're going to get code execution through that. Okay, very good one. Nice.
Yeah.
You want to go through that a little bit, or you're worried it's going to be like too many spoilers? Or we're going to get kicked out?
No, we've got at least 15 minutes.
Okay, cool. I'm going to do that. So yeah, so what's the code? That's the PHP code. So basically we have a way to create cookie, we create JWT. So here we have this PDF check, but it's not great because we have this .pdf that doesn't work because we don't do .pdf.php. Before that, we have another one, is when we move the uploaded file, we move it to that destination. So this is the base name of file.filename, so we're just extracting the file name from a path given by the browser, which is not necessary anymore because name is already doing that in PHP. Now PHP introduced full underscore name in PHP 8.1 that provides you or full path that provides you the full path given by the browser, but name is only the file name. And then we concatenated that with the username, and that's where we're going to move the file. So a good thing about code, big thing about code review is also assumption. Never making assumption. Like your assumption of the developers, like it's all about assumption. Got it correctly like that. I'm going to show you my name after that. Before. So here you say like username. Okay, you map it in your head. It's like okay, username. My username is sniff. So that's probably going to be /sniff/ whatever. But no fear is telling you that your username is not going to be .. And so you can have a directory traversal in your username. And that's, again, that's kind of good bug for code review because that's not something that is obvious when you're pen testing an app because you're not necessarily going to think like, what if my username is .. because I don't know where the files are going. But when you do code review, you see that and you're like, okay, what if my username is .. because that's actually uploaded like that. Another one, JWT. And the code is very similar in Golang. So that's the signature method, which is basically like creating JSON by hand. And like when I wrote that code the first time, I was like, nobody's going to believe that people are doing that. And I tell you, like I found like 3 or 4 instances of that, including in Tomcat. So yeah. So the famous don't hack me bro. And the verify function is really, another pattern that is really interesting in the verify function is so we split on the dot because it's a JWT token, so you got header, payload, and signature. JWT is another thing I can speak about for hours, interesting. What we do is we need to verify the signature. So first we check that the signature is not empty, and then we check that the signature matches the signature we have. So we compute the signature to make sure we are the same. That's a classic pattern of people only checking a value if there is a value. If here the signature is empty, that is going to go to that code here. So bypassing the check. And maybe it's a bit small. So this is only checking the signature if there is a signature. So I remove the signature, and I'm logged in at anyone I want. So that's my past. That was a pain to write, but that was before like ChatGPT, so I had to write that by hand. That's hard. I'm trying to find like the signature function. Oh yeah, it's the signature function. I didn't talk about it. That's doing a SHA-256 instead of a HMAC, and that's doing a SHA-256 of secret, and then the data is concatenated. There is something named length extension. Basically, from one valid signature, you can compute more signature, and you can use that to add a suffix to the data that is signed. Some crypto stuff that is good to know. So you should have an HMAC or using SHA-3 because that's preventing that attack. MD5 has the same issue. Also, I promised some.
Wait, the SHA-256 is going to be a fixed length. What were you saying?
Sorry. Yeah, because I'm on this week. I'm saying that you have something named length extension. So basically, when you're signing data, it's not going to break if I.
You'll find out.
No, that's not even working. So if I'm computing a SHA-256 or MD5 of a secret and some data, I got a signature. The problem with that is that an attacker is able to add some data to the existing data. So to be precise, the padding of the hashing algorithm plus some extra data, and compute new hashes that are going to be still valid, that are going to verify this signature. And I'm trying to find no.
It's interesting that GitHub uses SHA-1.
I don't. They don't have a choice.
Not only that, but I think you can use truncated hashes on GitHub to refer to commits. Find some private commits that way.
No, I can't find what happened. Yeah. I said I was going to show some memes. I spent today doing manual code review. Be honest, I'm being honest. What did you actually do? I run grep a few dozen times. Got another one. And that's the other one. Assumption curve. So I think we all know why we're here. Yeah. Yeah. Code review is a bit dry sometimes, even I can admit it, so you need to spice it up a bit. Oh, and also some good blogs, if you like code review, like most of these blogs are writing, like when they write about vulnerabilities, part of the write-up has code review inside it, like they're explaining with source code, so that's often a good way to learn new things.
Any other learning resources?
So, those are the slides of my 12 hours training. It's 1,007 slides. So that's how much I can talk about code review. That's 12 hours, so that's still pretty, I don't know. There's so many. It's a good code review. What you get out is what you put in. So many things to learn.
And then the whole PowerPoint will be with the video?
Yeah, I think we're organizing that. I don't know if it's like a one-to-one, but yeah. But yeah, a lot of content. Yeah.
Anything new with, so I'm guessing SemGrep is coming out with, already has come out with 2.0, something new that they're working on. Is there something new something that's interesting with, I guess, that?
I haven't looked at SemGrep in ages. I really like it.
I was just saying, like, anything new that's
I don't know.
new that you're promoting or something.
No, maybe.
It's for you. Like, what's happening with Pentester Lab?
Pentester Lab, like we do like a lot. So I used to do like only the online platform, and people will learn through the online platform with like Like for code review, we have like snippet in all languages. Then we have like diff of CVs, so you don't have to do the painful thing of like triaging CVs. That's a pain, so I do that for you. And then we have like small application that you can do code review, and we do that in a few languages, either as a mix-up or per language. And also like live training now, which is pretty amazing, and people seem to really like it. It's like 12 hours of me talking about source code. I'm not always that funny. I kept the best part for you guys because I really like you. But, no, it's a lot.
So you're giving live sessions?
Yeah, live session, but it's not as fun as today, but yeah, it's pretty interesting. Like if you want to scale up, that's pretty good. And yeah, that's what we do. We train like from students in like third world country to like big enterprise customer. Like yeah, we train everyone who is willing to listen to me, at least.
Do you notice a shift with any type of like AI tools or anything like that that could potentially down the line?
I haven't seen tools like there are a layer of AI on top of like stuff like SEMGraph, grep, and like for triage. I tried to feed, so I had like this brilliant idea, like get a CV diff with like hundreds of lines and pass it to like just get the file name of the that were changed in two versions of the same code, like fixed version to vulnerable version, pass the file name to ChatGPT and say like, this is advisory, these are all the files that got changed, which one is the most likely? That didn't work out for you. No, it didn't work, like, yeah, couldn't guess, like, okay, even if it was not too hard to guess, it was like, yeah, not doing great, to be honest. But I think that's, so I think that's why it's important to get good at manual code review and finding hard bugs, because I think what is going to go first are the low-hanging fruit, and that's what AI is going to find. Same for pen test, like hard bugs where you really need to think about stuff, and yeah, are going to be a lot harder. And if you're getting good at those, by actually reading source code instead of running grep, you got like longer lead time before AI replaces you. That's what I keep telling myself, at least. So far, so good. Me good? Yeah. Oh, yeah, I mean, I've run out of battery. No, I'm good. Good. But yeah. Good. Thank you for your time. Yeah, grab stickers, grab keyring. Come here if you want to grab the t-shirt.
There's still probably some